understand how it works, the practice. You don't have to code all of them, just copy and paste and compile with GCC in case of the C programming, or if you are using the Windows API, using the create processes, Windows, and there are a bunch of such a sample source code you can find easily, and also textbook provide. So also we have the exercise lab. Using that, even though we are behind of that, please in advance you can practice by coding and compiling. Then it will be helpful for your project also, even though you are using different program languages. Okay, then so what is this? Memory. So memory in the, but in this case we are going to consider this one as a process. Processor has the data and the text and data and the heap and the stack. So this is the general, very high level overview of the processor data structure. So when we create a process, this will be copied to somewhere on your memory. But during the fork, actually we do not copy this. What is the text? Text has the programming code. So it's actually a lot. So if you copy this one also, it takes a time. So most of the fork actually do not copy this. Instead, the point. Yeah. It shares the data on the memory. Okay? And the data is will be confused the code in the memory. Okay. Then during the EXEC, this will be disconnected instead. For example, its own code will be loaded. Okay. Or so sometimes this part, even though no EXEC, but if the code is changing, then it may be. But anyway, so this is how it works. That means when you create the process, it has a lot of I/O, including EXEC. You need to load. You need to allocate the memory and load into the memory data, which means it takes a time. So actually, one of the main issue of the managing the process is we try to speed up. Anyway, so we try to speed up overall operating system. But as we have seen the Chrome. This is a Chrome, and there's another processor for the Chrome. And Chrome, there are several processes. Do we need to exactly the same code or not? Think about your Microsoft Word. So what is the size of the Microsoft Word when you install? Several hundred megabytes. Then, how many functionality are you using? Only few of them. Actually, we don't need all of this. And also, when you create the multiple process in the process, they are sharing a lot of the information. So is there any way to save the data? So idea is simple. Why don't we share as many information or data as possible from the process? Which means if we see the structure of our program, so sometimes in case of Microsoft Word, we have the input, read the data from the keyboard, and display, output, and also spelling check function. They are part of the process. They are. So if we have the multiple processes for the Microsoft Word, this one actually exists here. And also a lot of the common data, like the global variable, we cannot have. If we have the copy of that, it's very hard to manage such a thing. And also a lot of data are shared. So idea is simple. Why don't we share as many information as possible? Then only create its own functionality. So how can you differentiate such a functionality? This one has sequence of instruction for the input. This one has sequence of the instruction for the output. This one has the sequence of instruction. So we regard this one as a thread. and thread, and thread. So instead of creating entire process for the specific purpose of the function of the program, instead we are going to create under one program just a multiple, such a small size of the process, which is called the thread. So thread is to simplify the creating process and also reduce the size of the memory. We are going to create the thread instead of the process. However, we already learned such a thread concept. In your Java programming, you already code thread program, like the sum. So I direct sum 1 through million. So you can implement summation function or class like the for input and output. Okay, then call this one as many times as possible. It's the same idea as this one. Instead, this is called application level. You can use the thread. It's called the user thread. But we are focusing on the overall system. Like the kernel also use the same idea. Because kernel is the first process, they are sharing a lot of system information and so on. So why don't we share such the resource as much as possible? Then create the thread instead of the independent, separate the processor. That is the example of, do you remember when I browse the list of process, some of them are bracket. Bracket actually such a thread. So it's a server-side thread. So user thread and the kernel thread. So we are going to talk about such a what is the kernel thread and what is the user thread and how they are working, because it's a two different modes, user and system mode, the kernel mode. Then at the time which one will be used and how to the mapping and so on. Then for the practical implementation, what is the possible thread library? So we need to use such a library, pthread library, and Java is also Java thread library, and so on. So we will see green thread, and there are several different threads. And also another benefit of such a using the thread is
Data sharing.
parallel processing. We can do the parallel processing also. So it's when you are taking the parallel processing, what is the name of the class?
Parallel computing.
Cloud computing process.
Parallel processing.
Yeah, parallel processing classes. So if you are taking the parallel processing class, first job is you need to model your program that fit to such a parallel. At that time, we can create the thread. Then thread will be assigned to the specific core or processor. Then you can get the benefit of the parallel processing. So in the next class on Thursday, it doesn't take a time because we already complete all the process management. So we will quickly see what is the thread, how it works, how to implement the thread, and followed by exercises. Okay, see you on Thursday. Thank you.